Good day and welcome back to the online course on groundwater quality. In this section, we are still looking at groundwater quality monitoring, and we are focusing on mapping and modeling of groundwater quality. The learning outcomes for this module looks at evaluating groundwater quality using models. And there are a variety of models that you can use. When we refer to mapping, we know that all point data can be mapped. So as long as you have coordinates for your sampling point, whatever data you collect can be put on a map. Examples of these: soil type, land cover, electrical conductivity, chloride levels, rainfall distribution. And we know that GIS tools are very useful in overlaying various layers of information. So as I mentioned, there are different ways in which you can look at your data, one of which is a conceptual model. A conceptual model is essentially a collection of hypotheses describing the understanding of groundwater systems. In other words, all the information that you're able to gather about your study area can be used to build a conceptual model for your area. Example, your geological setting, your rainfall, whatever data is available, you use to set up a conceptual model. So in essence, it can convey your understanding of a system. And these can be developed and tested during the course of a project or research. You can also use new results that you collect during a project to build or add on to your existing conceptual model. In other words, you can demonstrate new knowledge or a new understanding of your system from your initial conceptual model and then including your collected data during the project. So when we consider improving conceptual models, it does help you to identify knowledge gaps when you set up your initial conceptual model. You can also test the validity of the developed conceptual model by taking measurements where uncertainties exist. Building on existing knowledge to improve systems understanding is what you're doing when you are testing your existing conceptual model. You can also use the developed conceptual model to construct a numerical or chemical model for your study area. You are also able to test scenarios, which you can either use to validate or test the conceptual understanding of the area. You always have to do a conceptual model before you do a numerical model. So when we look at numerical modeling, it's quite complex and it takes into account all the physical properties of your aquifer system, your geological properties, your flow properties, your hydraulic properties, your water level information. You are able to use a combination of all the physical data sets. It can have quite large data requirements, but you are able to run scenarios, example, change in flow, discharge or recharge, and also the impacts of pumping on your water level, for example, or your sustainability of your aquifer system. Often in these numerical modeling software packages, particle tracking is used as a means to account for movement of contaminants. So taking then into account your distribution coefficient of your contaminant. Then if you want to do a chemical model, you can use reactive transport modeling. A package that I've used before is Freaksy. There are other packages available, which we discussed or mentioned in the previous, one of the previous presentations. So what is this used for? You can model chemical processes. You can also consider speciation of chemical constituents of the water, as well as the level of saturation with respect to certain minerals. Then you can also do batch reactions. And it shows you your saturation indices of all possible mineral assemblages. Importantly, the output is based on your input solution chemistry. You can also simulate mixing of 2 or more different water compositions. In fact, you can use water versus soil chemistry and also do mixing to look at the resultant water composition. It's also possible to simulate redox processes, biomass growth, and remediation reactions over time. Transport and reactions along a flow path can also be simulated, and forward and reverse modeling can be achieved using Freaksy. Sorption and desorption, surface complexation reactions, even ion exchange can be modeled. And you can account for gas phases, pure phase, solid solution, and surface complexation assemblages using the software. So it's very useful. I've used it for remediation reactions. You can also use it when, for example, if you're doing managed aquifer recharge, to use your source water and your aquifer composition and do mixing simulations to see what your resultant water is likely to look like. You can also predict things like clogging if you were doing mixing modeling, for example, because it gives you speciation and it gives you saturation index, so you can see which minerals are likely to precipitate out of solution when you do your mixing simulations. It's a very, very useful and very powerful software package. You can also find software where Freaksy's capabilities are linked to your numerical modeling capabilities. And these would be even more powerful because then you can show your reactions along with your groundwater flow and hydraulic properties. So I've got your network design, setting up your network and modeling. I know we've done the network design before, but I just want to urge you that if you are intending to do modeling, it's very important that at the stage where you are still designing your monitoring network, that you account for all the variables that you're going to require to set up your model. Otherwise, you could have a project reaching its end and you discover that, oh, I needed to do water level, but I've only got chemistry. So it's of key importance when you are designing a monitoring network and you have an intention to do modeling, that you look at your model input requirements and align these also with your data needs, which link to your objectives. So with that, I thank you, and I trust that you've gained some new knowledge from that presentation.